Hi friends, so we are going to learn about the surface tension on liquid jet. So let me show you one example here. So if you see here, there's a tap of water releasing water into the environment. This water surface, if you see from here to here, the water coming out from the tap is in the form of a cylinder. So the formation of surface of a cylinder is due to the surface tension of the liquid coming out from the tap. Now due to the surface tension inside there will be pressure buildup more than the atmospheric pressure. Because this surface is formed, so this surface will create an excessive pressure inside from the outside pressure. Okay, so this is the cylindrical liquid surface of the jet coming out from the tap of water. Now this formation of surface is only due to the surface tension, and since there is surface tension there has to be excessive pressure inside the cylinder over here, friends. So we are now trying to find out the relation between the excessive pressure inside and the surface tension which is acting on the surface of the cylinder. Now I'll draw this cylinder separately. So this is diagram which shows the half section of this particular cylinder. Inside it is completely filled with liquid and outside there is a air over here. So if you look at here, friends, there is a single surface or single interface between the outside air and the inside liquid. So the surface tension forces are going to act on this line basically. So they are going to act like this, in this way. So the surface tension forces are going to act like this. Here also you will getting surface tension like this. It is going to act perpendicular to the line. So the diameter of this liquid jet is D, let's say. So this is diameter of jet, and the height from here to here, let us say it is L. So from here to this level we have, this is going to be L, that is length of jet. Okay, now as we have already discussed, there will be inside excessive pressure will be built up. So inside pressure which is Pi, and from outside the pressure which is acting will be the atmospheric pressure. So I am going to call it as Po. Okay, so inside pressure is Pi and the outside pressure is Po. Now on this surface which is inside the cross section of this jet, there will be net pressure is going to act, and that will create a force on it, while these surface tension which is at sigma over here, they will create a force acting on the length. So we know that the surface tension is force acting on unit length. So force per unit length, friends, like this. So if you see here, friends, only interface line is coming here and interface line is coming here, while this line is inside the liquid, so there is no surface tension over here. This surface tension is acting on this line and this line. So the surface tension is basically force per unit length. So if I want to find force due to surface tension which is acting on these two lines, okay, will be equal to surface tension times length. So length, if you see here, there are two length on which surface tension is acting. So overall length is going to be 2L. Okay, and secondly we have the force acting due to excessive pressure inside and outside. So inside pressure is Pi here, and then outside pressure is Po. So therefore I can also write down force, and this force is acting on this internal area of the cross section of jet. So force due to delta P, that is excessive pressure, will be equal to, if I write here, it will be delta P times area. Area is very simple here. Area is nothing but the length into breadth. So breadth is basically D, that is diameter of the jet. So it will be L times D. Now under equilibrium condition both are going to be balanced. So under equilibrium condition, in equilibrium I can write down this force and this force will be balanced, friends. So we'll get sigma times 2L will be equal to delta P, that is excessive pressure, times L times D. So if I simplify this equation, sigma is going to be, I can cancel out L on both sides. So from here you'll be getting the surface tension will be excessive pressure of jet times diameter of jet divided by 2. So this is the expression of surface tension of a liquid jet having excessive pressure delta P and the diameter D. From here you can also find out the expression of excessive pressure. That is very simple. So you can get from here delta P, that is excessive pressure, will be equal to 2 times sigma, that is surface tension, by D. This is also a straight outcome. Okay, so both expressions are important. Let's do one problem based on the concept of surface tension of liquid jet so that we'll be able to understand it properly. So I'm going to show you one very simple example and we'll try to solve that example with the help of the learning we have made so far. Okay, so let's see here. We've got a very simple example, friends. A smooth cylindrical jet of water issues into air with diameter of 2 mm. So there's a jet of water which is being issued into air and having diameter 2 mm, right? The water surface tension is given as 0.02 Newton per meter, and the density, mass density of water is also given, that is 1000 kg per meter cube. So we have to find the excess pressure inside the jet over the atmosphere, that is delta P we have to find, due to surface tension. Obviously it is due to surface tension only, and then express this excessive pressure as an equivalent head of water. So there is an additional point, friends. We have to also express this excessive pressure in terms of water head. So we'll do first part, that is excessive pressure, and then subsequently we'll try to do the second part, which is the pressure head. Okay, so let's see first part. Now let me take down all the data available to us. So whatever is given to us, let's see what is given to us. So a smooth cylindrical jet. So jet is in the form of cylinder, issues into air with a diameter of 2 mm. So diameter of jet is given to us, friends, which is very important. Diameter is given as 2 mm. So 2 mm we have to write in meters. So it is going to be 2 into 10 raised to minus 3 meters. Secondly, they have given the surface tension of water at the given temperature or condition of temperature. So it is 0.072 newtons per meter. That's okay. And they have also given us the density of the water, the mass density of water, that is obviously 1000 kg per meter cube. In general, we take 1000 kg per meter cube as a mass density of water. And we have to find the excess pressure inside the jet over the atmospheric pressure. So we have already done it, friends. So excessive pressure has an expression 2 times sigma by d. So straightforward, if you put this expression, because the conditions are matching, so I can say the excessive pressure. So excessive pressure basically is given as delta P, and delta P is 2 times sigma by d for liquid jet. So let me put these values into the expression. So 2 times sigma is given as 0.072, all are SI unit, no problem. And by d is again 2 into 10 raised to minus 3 meters. Okay. So if you simplify this expression, you'll be getting delta P as 72 Pascal. It is going to be, friends, 72 Pascal. Straightforward. A simple calculation. Now second part. So if you want to express any pressure in terms of pressure head, so generally we write pressure head as H. So H is given as, friends, the actual pressure in terms of Pascal divided by mass density into gravitational acceleration. So this value is there. So if I do it like 72 is the actual pressure in terms of Pascal and divided by mass density is 1000 for water, friends. This is the pressure head in terms of water I am finding out. I can also find out by other fluid, but they have given pressure head in terms of water. So it is going to be density is 1000 and G is 9.8. If I simplify this, so it is going to be 7.34 into 10 raised to minus 3 meters. So they are asking the pressure as an equivalent head of water in terms of mm. So in terms of mm, I can write down simply H equal to 7.34 mm. So this is the simple procedure you can adopt to find the value of excess pressure inside a liquid jet when we know the diameter of jet and the surface tension of the liquid of jet. Okay.